Welcome to tabtalkers.com. We are here again for our interesting topic of mechanics, applied mathematics, and that is what we are calling component and the resultant force. That is our new unit of mechanics. We are now on the third one. So we are going to look at what we are calling component and resultant of forces. And now to begin with, let's first look at what we are basically calling component of a force. Okay? It is some interesting old word. I cannot say it is a new word, component. Part of, isn't it? I think that it should mean something like that. Component, parts of, isn't it? Parts of forces. Something like that, okay? So if you say a component of a computer, a component of this, that means it is the part. You bring this, it forms something. So it is part of something. So if you say component of a force, that means that is part of a given force. That means forces also have some parts. So now, if forces have some parts, what do you understand by the word component of a force? So if we are talking about component of a force, we are basically meaning that a component of a force F is the effect of a given force in a given direction. So you can write and say a component of a force F refers to the effect of the force in a given direction. Is that okay? So we are saying that what we are calling a component of a force, we are trying to look at if we have a force. An example that we shall be dealing with is if I have a force in this direction, maybe a force F at some angle here. This is in y direction, this is in the x direction. So this force is in this direction, isn't it? Not in y, not in x. But we may decide to say, what is the effect of this force in this horizontal direction? What is the effect of this force in this direction? When we start analyzing in terms of direction in y, direction in x, there we are now talking about the component of this in this direction, the component of this in the other direction. So that is what we are calling the component of a force. Okay? And now we can say a component of a given force is always, a component of a given force is always perpendicular to each other. Okay? So we are saying that if we are looking at a component of a force, that the moment you get a component of a force, maybe say it could be horizontal or vertical, or you could say in x and in y, those two components must always be perpendicular to each other. And then after knowing that the component of a force should always be perpendicular to each other, we can also say that the process of determining the component of a force is known as resolution of forces. That is a very important word that we shall be using now. When we say resolve the following, the following forces, what are we meaning? We are just saying that get the components of the forces and in directions which must be perpendicular to each other. So the process of getting the component of forces is what we are calling it resolution of forces. So now, if we are to talk about resolution of forces and say resolution of a forces is the process of splitting a given force into its Freit components. The Freit components, we can also call it what we are calling resolutes, isn't it? And resolutes are the components of the forces. So resolution of forces is the process of splitting a given force into a Freit component. So we can say resolution of forces is the process of splitting a given force or forces into a Freit component known as resolutes. We can call the component a resolute. So after knowing that, you should note that before resolving a force, the direction of the force of the forces must be established first. Okay? So we are saying that before coming up with the idea of resolving a force, you should first establish the direction. I'm going to resolve in which direction, in x, in y, to vertical, horizontal, something of the kind. Should first be established. Okay? Let's look here at some illustration here. How do we resolve forces? Illustration. We can say find the vertical and the horizontal component of the forces given below. So if I can have here my A, if they tell you you have a force like this, and I can say this is maybe my 3 newtons at an angle of 60, and this is Y, you establish that as X. And then part B, I can bring almost a related idea to that. That is X, this is Y, and now my force is here and it's supposed to be 4 newtons, and now we are saying that our angle here is 45. Okay, and then if you have this, you can also try this as well, and then look at what happens in such a scenario when this is supposed to be 30. Just to begin with some simple stuff like that as our illustration to understand the process of resolving the forces. The process of resolving forces. Please, these statements here are very important. Some words will actually guide you so much, like when you say, before resolving a force, please make sure that you note the direction, because we shall bring the element of calling a certain direction a negative, another direction as a positive. So if you are not confident with that, you can resolve a number of forces, but if you don't attach the meaning of every force by sign negative, positive, and then that means that you've just done nothing in your solution. So how can we now resolve this kind of problem here? So for this part here, if we are to resolve a force, what we do is, I can first start by resolving now from first principle. I can draw this and I form a triangle. You can now look at it in this, it is some triangle of hypotenuse 3, and now we have here x, we have this direction as y, and we say the components are always vertical and could be x or y. So how do we determine that? So if we are beginning from our first point, we can now say, from this right angle triangle, we can say, what is the cos of this angle here? Cos of 60. You realize that cos is supposed to be adjacent hypotenuse. And what is my adjacent? My adjacent is the x value. Okay? Divided by the hypotenuse, which is the 3. Okay? And now what is my x if I cross multiply? It will mean that x is equivalent to 3 cos over 60. Is that okay? And this is what we are calling the component of the 3 Newton force in x direction. Okay? So this one is now what we are calling a component. But a component of what? A component of the 3 Newton force in x direction. And then we can go ahead and also look at what about in y, because they said find the horizontal and the vertical, isn't it? The horizontal is the one in x, and that is 3 cos over 60. And then this will be Newton. And then we can also now say, what about if we look at the sine of 60? Okay? Sine 60, sine is supposed to be opposite hypotenuse. What is the opposite of this triangle here? You realize that it's supposed to be y out of the hypotenuse is the 3. Also, if we bring the idea of cross multiplying, our y will be equaling to 3 sine over 60. Okay? And now this is what we are calling, this is the component in horizontal, or what we call horizontal component. And then this is what we are calling the vertical. Isn't it? Because by convention we are taking the vertical direction to be y. So this is the vertical component. Okay? That is how we establish components of a given force. Now, let's now maybe look at this part here, and then you'll try this other last one. How do we get the component of this one here? You realize that horizontally here I can say this is x, and vertically downward here this is y, isn't it? But going down. So also from here, if I decide to say, what is the cos of 45? Cos of 45 is equaling to opposite, cos is equaling to adjacent hypotenuse, and that is x over hypotenuse is 4. That means my x is the same as 4 cos of 45. Okay? And now this one also, for this one here, it is representing the horizontal component, because x will be for horizontal, y will be for vertical. And then basically we can also look at if we are talking about sine of 45. Sine 45, will be equaling to opposite y out of hypotenuse 4, and y will be equaling to now 4 sine of 45. Okay? But now on this one here, I'm going to this y here, I can basically attach a negative on it. Why am I attaching negative? Because the direction of y you're seeing, I've drawn it sloping down. The direction is downward. Therefore, it is in a negative direction. And that's why I'm attaching here a negative on y, because it is moving in the negative y direction. Please, all these directions are positive and negative. For x, positive, negative. So, this negative here instead can also come here. And now this one will act as what we are calling the negative, the horizontal, this is the horizontal and this is the vertical direction. Please, using this idea here, I beg that you first try getting the component of this last force. We meet in the next part.